Assalamualaikum and hi everyone. My name is Sharifuddin, and today me and my partner Hazim will be discussing 4 different types of questions in our calculus assessment. So for me, I'll be covering question 1 and 2, and my partner Hazim will be covering for question 3 and question 4. So this is our group member. It is just me and my partner. My name is Sharifuddin bin Muhammad Nazri, and my partner name is Muhammad Hazim bin Azman. So let's jump to question 1. Question 1 asks us to explain the meaning of differentiation in mathematics. So in mathematics, differentiation is a process of finding a derivative of a function. Geometrically, it is measured instantaneously rate of change of a dependent variable with the respect to an independent variable. So as you can see right here, we have an example. Rate growth of a tree over the time. So in this case, the dependent variable is the height, the outcome, and the independent variable is something that we decide, which is the width. So as you guys can see, during week 2, the height of the tree is 5 cm, while during the week 6, the height of the tree is 15 cm. So using differentiation, we can predict the height of the plant for the upcoming weeks. And for a curve plotted on a graph, the derivative at any given point gives the gradient, which is the slope of the tangent line to the curve at a specific point. So as you can see right here at point A, the slopes becomes 0, which is flat, and during at point B it is going upward, so the slope becomes positive, while at point C the slope is going down, so the gradients become negative, and for point D it is just the same as the point A, which is 0, and it becomes flat again. So moving to another part of question 1, the question asks us to name 3 techniques of differentiation that you have learned in the syllabus. So in my syllabus, I've learned 3 different techniques of differentiation. The first one being the chain rule, and the second one is the quotient rule, and the third one is product rule. So let's go to a bit more detail about the rules. So for chain rule is used to find the derivative of the composite function. So the formula for chain rule is dy over dx equals to dy over du times du over dx. So as you guys can see, the du from above and the bottom can be cancelled out, so we could get dy over dx back. And moving on to the quotient rule. The quotient rule is a method that is used to find the derivative of the function that is ratio to two differentiable functions. So for quotient rule, it's quite complicated because it is the most complicated of them all. So the formula is dy over dx equals to u prime times v plus v prime times u over v square. So and last but not least, the final rule is the product rules. The product rules is a formula that is used to find the derivative of the product of two or more functions. So product rules is actually quite similar to the quotient rule, but it's quite easier. So the formula is dy over dx equals to u times v primes plus v times u prime. So let's go to question 2. Question 2 asks us to differentiate the following function with the respect to x. So we have two questions here. A is y equals to 5x power of 3 exponent cos x. And for question B, fx equals to ln 5x over sine 2x. So for question A, we're going to use product rule, and for question B, we're going to use the chain rule. So let's start with question A. So we're going to apply the product rule. Dy over dx equals to u prime plus v u prime. So for u, we're going to get 5x squared, and for u prime, we're going to get 15x squared. And for v is e power of cos x, and when we differentiate it, we're going to get v prime, which is e cosinus x times minus sine x. And we're going to apply the product rule, which is dy over dx. So we're going to put 5x power of 3 exponent cos x minus sine x plus 15x squared times exponent cos x. So we're going to times them all together, and we're going to get minus 5x power of 3 sine x exponent cos x plus 15x squared exponent cos x. So when we factorize them, since both terms have exponent cos x, we're going to put that to the front, and then we're left with 15x squared minus 5x to the power of the 3 sines x. So to make the answer more simplified, we're gonna extract 5x 5x power of 2, and then we're gonna get the final answer, which is 5x power of 2 exponent cos x times 3 minus x sines x. Now we have done with question A. Let's move on to the question B. So for question B, we're gonna use the chain rule, which is dy over dx equals to dy over du times du over dx. So actually in this question, we must use the quotient rule, but we can avoid using the quotient rule by applying log property, which is in this case ln a over b is ln a minus ln b. So we're going to apply the log property to our question, and we get fn equals to ln 5x minus ln sines 2x. So we're going to differentiate for both of them. So for ln x 5x, we're going to get, we differentiate ln, and we're going to get 1 over 5x, and then we're going to differentiate 5x, which is just 5, and then we can simplify both terms, and we get 1 over x. And for ln sin 2x, we're going to differentiate, and then differentiate ln, we're going to get 1 over sin 2x times differentiate sine, we're going to get cos 2x times 2, because we're going to differentiate 2x, and then we're just going to get 2, and then we simplify, we're going to get 2 cos 2x over sin 2x. And then after that, we're going to combine both of our outcomes, and then we're going to get fx equals to 1 over x minus 2 cos x over sin 2x. So to make the answer more clear, we're going to combine cos and sin, and then we're going to get the final answer is fx equals to 1 over x minus 2 cotangent to x. So that's all from me, and we're going to go to question 3 with my partner Hazim.
Assalamualaikum, my name is Muhammad Azim, and today I'm going to solve the question 3 and 4 for the assessment 2 MAT183. So moving to the question 3, we have given y sin to x minus ln to y equal to 2x squared plus 3. Find dy dx using the implicit differentiation. So in this equation, we see that we have left hand sides and right hand sides. For the left hand side, we got y sin to x minus ln to y. For the right hand side, we got 2x squared plus 3. So we are going to solve the left hand side first. For the first term, we have y sin to x. So using the product rules, we can differentiate it with we know that product rule is u prime times v plus v prime times u, right? Okay, so for the u equal to x, we can differentiate it to u prime equal to dy over dx. For the v equal to sin to x, we can differentiate it to v prime equal to 2 cos 2x. So for the first term, we can see that du over dx, differentiate it, we need to combine all to the product rules. So d over dx times y sin to x equal to dy dx times sin to x plus y times 2 cos 2x. So we can see that, we can conclude that this product rule can be written by the equal to sin to x times dy dx plus 2y cos 2x. Moving to the second term, which is ln to y. To differentiate ln, we know that 1 over the terms or something like that. So d over dx for ln to y equal to 1 over 2y times 2 dy dx. So we can eliminate the 2, which can be 1 over y, and the y that we differentiate earlier, we can write it as dy dx, so we can say it so equal to y over 1 over y times dy over dx. Moving to the right hand side, which is we got the 2x squared plus 3. Just normally differentiate it, so d over dx, 2x squared plus 3 equal to 4x. 2 times 2, 2x times 2, we got 4x. For the 3, we got the x have no power, so equal to 0. So what can we say? We need to write it all together. So from the equation earlier above, so sin 2y dy dx plus 2y cos 2x minus bracket 1 over y dy dx equal to 4. So we need to change the position where dy dx go to the left hand, go to the left side, where the term that have no dy dx go to the right side. So we can write it as sin 2x dy over dx minus 1 over y dy over dx equal to 4x minus 2y cos 2x. Now we can factorize the dy over dx, so it will be dy over dx times sin 2x minus 1 over y equal to 4x minus 2y cos 2x. So we can conclude that we can divide the dy over the sin 2x minus 1 over y to the right side. So the final answer will be dy over dx equal to 4x minus 2y cos 2x over sin 2x minus 1 over y. Moving to the question 4, where the question given us the I read the question. Use linear approximation to estimate the value of set 4 15.98 minus 2 over set 15.98 correct to the 3 decimal places. So first step, we need to simplify it to the x form so we can easily differentiate it. So as I wrote it here, let fx equal to x to the power of 1 over 4 minus 2 over x to the power of 1 over 2. So what we can differentiate it, so f prime x equal to 1 over 4 go to the front, which is times 1 because it's 1x. 1 over 4x, 1 over 4 minus 1, it will be negative 3 over 4. For the 2 over x 1 over 2, it will be negative 2 x to the power of negative 1 over 2. So to negative 1 over 2 will multiply with 2, so it will be positive 1x. Negative 1 over 2 minus 1, it will be negative 3 over 2. We can see from the equation, which is 15 over 998 is near a value of 16. So we can conclude that we can use 16 for the nearby value to estimate the approximation. So first of all, we need to find f16. So f16 here is equal to, just write it all back, 16 to the power of 1 over 4 minus 2 over set 16, which will be 2 minus 2 over 4, and it will be 1 over 5. So that's our f16. So next we need to find f prime 16, which is, just use the differentiation equation that I have wrote it earlier. which is 1 over 4 x to the power of negative 3 over 4 plus x to the power of 3 over 2. Just put the 16 into the equation. So it will be written as 1 over 4 times 16 to the power of negative 3 over 4 plus 16 to the power of negative 3 over 2. So we can write it down back. Just write the numbers. 1 over 4 times 1 over 8 plus 1 over 16 equal to 1 over 2 plus 1 over 64. It will be 3 over 64, and that will be the number for our f prime 16. To find the linear approximation, we have an equation which is Lx equal to f times a plus f prime a times x minus a. So just wrote it all the numbers that we have got from the problem that we have solved earlier. So just wrote it into put it into this equation. Fa equal to 1 over 5 plus f prime a equal to 3 over 4. Okay, for the x minus a is we know that x equal to 15 over 15.98. We chose the near value which is 16, so we need to minus it. So it can be written as Lx equal to 1.5 plus 3 over 4 times 15.98 minus 16. Okay, it can be written as just 1.5 remain minus 3 over 64 times negative 0.02, and it will be 1 over 5 minus 3 over 3,200. So just do it. It will be, the answer will be 1.4990625. According to the question, we just need to 3 decimal places, so we just take 1.499. So that's the final answer. Thank you.
So that's all from us, and thank you for listening, and I hope you guys have a wonderful day. Goodbye.